So malady debarkment. So the reason why it's even a thing is because our vestibular system is constantly adapting to our environment. And we need to know when we're in motion and when we're stopped, when we're still. We have two very important systems. One is our rotational vestibular ocular reflex, which means I rotate my head and my eyes go opposite and equal. I also have my tilt ocular reflex, okay? So when I tilt my head, my eyes are going opposite and equal, and it has like a torsional aspect of it. Your brain does not know the difference of rotation and tilting, okay? And we piggyback and we use these different pathways to discriminate. Are we rotating our head or are we tilting our head? Now, when we have these sensations of rocking, bobbing, swaying, we already know that we have some issues within what's called your otolithic system. So we have two parts of our vestibular system, semicircular canals, which are rotational in nature, right? And then the otoliths, which are translational. So what that means, when you're on a boat, you're translating. When you're going up and down like this or on the horizon, you're translating. When you're rocking side to side like this, it's a translational aspect. When we get in a car, we're translating, right? We're going forward or backwards, acceleration force within gravity. Otoliths are always on. So that's the other key to this, because the disorder itself, it's so difficult and there's so much suffering involved in it, because that part of the vestibular system never turns off. People that get vertigo, there's a time constant to it. So generally it's shorter lived. That system is really, really important, but it's not nearly as complex as our otolithic system, because that's actually the system that keeps us alive even when we're sleeping and laying down, okay? So we typically think of our vestibular system as just being a balance system. It's so much more than that, okay? So what happens is people can go on a cruise, on a boat, or sometimes it happens on planes, car rides. Most often you hear it with a cruise. You go on the cruise, and on the cruise, what's happening is you're getting passive motion. So the boat is creating this rocking for you. That type of passive motion can create what we call a maladaptation. So my brain is constantly changing based on what I'm doing. So when I walked in this room and I sat down in this position, it detected, hey, she's sitting down, she's staying still. She's not spinning, she's not rocking and bobbing. When we go on a cruise, your brain is having to say, okay, we're on a cruise and we're getting this constant passive motion, but it's temporary. The people who it's not temporary for, their brain ends up adapting to have these neuroplastic changes as if it's a permanent thing, as if your world went from being still to a world that's constantly moving.